Welcome everybody to this video where I'm going to go over how to use some technology to tackle some of these more complex equations and formulas in the finance world. So things like compound interest, savings plans, mortgage payments and payment plans and whatnot. So there are really three main ways to always tackle these problems. One, you can pretty much do them on paper, with the help of a calculator. Two, you can use a graphing calculator and, with enough skill and parentheses, you can just type the whole darn thing into it all at once and hit enter. And then three, what I think is the easiest and most beneficial is in Excel. So I'm going to start with the Excel example. Then I'm going to move on to typing everything into a TI calculator. And then the last thing I'm going to do is show you how to just do it in a calculator, regardless of if it's a fancy one or not. All right, so let's go through some simple examples. Here's our first example where we are asked to do some compound interest on a starting principal and then figure out how much money we have at the end of things. So just know that what we're doing here can be used with any kind of compounding. The example I'm doing here is it's going to be monthly compounding, so n is 12, but you could make a very simple change, right, for quarterly compounding where n would be 4, or daily compounding where it would be 365. The only thing that we couldn't do with this stuff is continuous compounding, but that formula is really easy to work with. And I'll show you that when we do the formula portions and how you can type that thing into any calculator without any problems. Okay, so first things first, let's do it the Excel way, because that I think is not only the easiest, but it helps you develop some very important Excel skills, some basic Excel skills, which are always good for really almost any job out there. So what we're going to do is we're going to set up this little kind of machine, right, formula machine in Excel, where we can then tackle every problem over and over and over again, and all we have to do is type in the new numbers that we're given, right? So for these types of questions, they're always going to give us the starting principal, P equals, in this case, 5,000. They're always going to give us the interest rate, either listed as APR or sometimes just listed as a little lowercase r for rate. And just know that if they give you any of these as a percentage, so if they tell you the APR is 3%, you always have to work with your percentage rates, your APRs, as a decimal. So you would have to convert that to 0.03. And of course, if it was like 2.5%, it would be 0.025, right? So you just always have to convert it to a decimal. Okay, N is always the number of compounds in a year. So if we're doing monthly compounding, it's 12. If we're doing daily compounding, it's 365, and so on and so forth. They'll always give you that. And the last piece of information you're always given is how long we're doing this, right? Are we going to compound it for 2 years, 3 years, in this case, 5 years? So now we know what everything is. It's just a matter of plugging everything into Excel. So let me show you what I've done. And I like to label things so when I come back to this, 2 months later to, do a final exam, I can remember what the heck this thing is doing. So I labeled it, it's compound interest and savings plans. And then I labeled each row. So the first one's going to be my APR, and I reminded myself that it's interest rate as a decimal, right? N is the number of compounds per month, Y is the number of years. And then these things in bold are what is needed for Excel to run its future value function. That's right, Excel has this awesome function built into it that as long as you tell it these four things, you give it rate, N per, payment, and present value, it will calculate the future value. It will basically tell you how much money you have in your account at the end of, said amount of time. And the nice thing is it's versatile. Not only will it do just simple compound interest formulas where you just slap some money into an account at a certain interest rate and then leave it alone, and after so many years you have this much money in the account. It will also do what are called savings plans or annuities, where you make regular payments into an account. So like you set up an account where every month you put $100 into that account, and then at the end of 10 years, how much money do you have? It can actually give you the future value of that as well. So for this example, we're just doing compound interest. We've got our 6%, right? Our number of compounds per year was 12. They told us our Y was 35. And then rate is calculated for us. So, maybe you want to highlight the things that you type in yourself, right? So we're going to type in these numbers. This one's calculated for us. This one's calculated for us. This one we have to type in. This one we have to type in. And then the bottom one is calculated for us. So this is the information they give you, right? They give you the interest rate, number of compounds, how long it is. And then down here, this would be whether we're doing, payments per month or we start with a present value. So in this example, we're not doing monthly payments, right? Amount paid each month. We're just doing a straight savings plan. And if we go back to the question, how much are we putting in, right? Our starting principal is 5,000. So we're going to put 5,000 in here. And that gives us the answer right off the bat. I mean, it's immediate. And if we go back to here, we can see that the answer is completely different, because what did I mess up? I see it. I've got my APR wrong, right? 3%. I think I have 6% from a previous one that I was working on. Yep, sure enough, there it is. Okay, 0.03%, 12 years. And I think I also have my years wrong. Years are 5, right? I've been playing around with this before I made my video. Okay, $5,808.08, and that is what we see is the answer. Okay, so it works as long as you're not stupid and putting the wrong numbers like I did. But the point is, I wanted to show you also that by just changing those numbers, you can get new answers. So when you come across a second question and it says, okay, now we're going to have 0.0425, right? So we're going to have 4.25%. And instead of monthly, we're going to compound it daily. And we're going to do that for 10 years. And our starting principal is only 200. Well, that's how much we would have. Not a lot, because we didn't start with a lot, right? So it's a very versatile thing, because all you have to do is change the numbers they give you. Now over here, this is set up for payments, and you can see again that these numbers are all typed in. So maybe we want to highlight those in yellow. This one's computed, this one's computed, this one's computed, this one's typed in, this one's typed in. Now for payments, this is one of those questions where it says, you borrow so much money at such an interest rate that's compounded this way for this long. What are your monthly payments going to be? Right? Basically figuring out what a payment on a loan would be. And so the future value is always 0, because if you're paying down your loan, it has to end at 0. The present value is basically how much you're borrowing. This is the interest rate you're being charged. This is how many payments you're making. This is a number of compounds per month. This is number of compounds per year, dummy. And so in this case, since we're doing 12 compounds per year, i.e. monthly, and that's what most loans are, they're always monthly. And then for how long, and then everything is calculated for you. So in order to pay off $7,500 in 10 years with a 9% interest, you have to pay $95.01 every year. Okay, so it's a very simple program to do. I'll show you what the programming was, right? And it's right here. To do rate, it's just APR divided by N. So I just told it was APR divided by this, right? I just programmed it as that cell divided by that cell, okay? And then for this one, we need N per, which is basically the total number of compoundings, which is how many we do per year times year. So you can see that that's just the number of compounds per year times how many years we do it. And then you can see why that number is 3,650 because it's just 365 times 10. The present value, remember these things we fill in. And then down here, this is just the future value formula. And the future value formula, as you can see, it tells you right at the bottom what it needs for each thing. So the first thing you give it is rate. So that's why I gave it B5, and then a comma, and then N per, which is B6, then payment, which was B7, present value, which was B8, and then the type at the end, you just leave it alone. It defaults to 0. And what that does is it defaults to if you're doing payments, it defaults that you always make your payment at the beginning of the month, which is standard. And if you're doing money earned, it defaults to calculating interest at the end of the month, which is the default. So you will almost never have to change that. I mean, you'd have to have some really weird, silly question that wanted you to do that differently. Okay, and then this table over here is something I created really quickly to show you your monthly payments and how it breaks down your balance. Don't worry about that. This is what's important, is learning how to do this one, right? So again, over here, same formulas, right? We're still just calculating APR, right? Divided by this. We're calculating, APR divided by that one. And then for this one, we're doing number of compounds times years, which is why we have 120. And then this is the formula PMT for payment. And again, you can see it tells you what it needs, rate, N per, present value, future value, and you just, again, type blank as 0. And so you just tell it where all those things are, and blammo, it gives you your payment. So it's a very robust thing. One more example, let's say if we were doing one of those annuities where we're putting money into something, right? So we're going to save money at 5%. We're going to make monthly payments. We're going to do it for 10 years. We're going to start with no money in the account, but we're going to put in $100 a month. That's how much money we would have at the end of 10 years. Now, if you think about it, you do 120 times, you're making 120 payments per year because you're doing, you're doing 120 total payments, right? Because you're putting $100 in per month for 10 years. So really, you do 120 of these 100s, so that right there is going to be 12,000, right? So 12,000 of this was just your money, but that's pretty darn good that in 10 years you made 3,500 and some odd change in interest. So that's the power of compounding, guys, and that's the power of Excel. Okay, if you want to do some of these things in your calculator, then you have to use the formulas. And they can be a little tricky. Okay, so let's go back to if we had a somewhat fancy calculator and we wanted to do this, and we'll go back to the original one where we're just putting 5,000 in for compound interest. Okay, so all you have to do is basically type in everything as the formula shows, right? So we got 5,000 times parentheses 1 plus 0.03 divided by 12, close parentheses. Then you have to raise it to a power, right? And the raise it to a power is this little button here. And then you can see it puts it up there. And then up there, it's going to be 12 times 5. Now, of course, you could go, well, 12 times 5 is just 60. You could do that, absolutely. And then just hit enter. And there's your answer, okay? It's nice and simple when you can use parentheses. Now, if you have a calculator that doesn't have parentheses, because it doesn't have to be a graphing calculator, even a basic calculator with parentheses, then you just have to do it by order of operations. And so by order of operations, we have to remember we do PEMDAS, right? Please excuse my dear Aunt Sally, do things inside the parentheses first. So the first thing we have to do is everything inside the parentheses. So we go 1 plus 0.03 divided by 12. Hit equals. That gives us that answers. Now, don't clear it, right? All you have to do is do the next operation. The next thing we do, right, is exponents. So then you do raise that. You see how it says answer raise. So it's taking the previous answer and it's going to raise it to, I'm just going to put in 60 because we know 12 times 5. Then we can hit enter again. That's our next step. And then the last thing we want to do is just do times 5,000. And there's our final answer. We round it to 2 decimal places because it's money. Okay, so that's how to do the compound interest formula, which is pretty basic. Now, of course, if you're going to do continuous compounding, that involves E, and there's not an Excel. I didn't do that one in Excel because it's really easy to do that one in the calculator, and I'll show you that one real quick right here. Okay, so let's remind us for continuous compounding interest, we have that your amount equals your starting principal times E. Remember, that's that special number E, raised to the power of R times Y, your APR, right, your interest rate times number of years. So we can use the same information for this compound interest formula, except instead of doing it monthly, we'll do it continuously. So we've got 5,000 as our starting amount, and then our interest rate was 0.03, and then we multiply that by 5 because it was for 5 years. Now that's really easy to do in the calculator, right? We can literally just do 5,000 times, you really don't even need the times, but it's nice to be thorough. You can see down here is natural log, so if you do second E, it brings in the E, and it already puts the little cursor up there for the power, which is 0.03 times 5, and then hit enter, and there's the answer. And you can see that it's just a little bit more, and that's all continuous compounding does. It gives you a little bit more. Now, of course, as the longer it goes, if it was 50 years instead of 5 years, the difference is going to get much bigger. And so that's how you do it in a calculator. Now, if you didn't have a fancy calculator, you could do, well, I mean, it would still be really easy even without a fancy calculator because there's no parentheses there or anything. Every calculator is going to have an E button. It just depends on how it works. Sometimes you have to type in the number first, so like you would do 0.03 times 5, and then hit enter, get that number, and then do the E button, and then it'll make E raised to that power, and then you would take that and go times 5,000 and hit enter. You just got to figure out how your calculator works. Most of them you do the E button first, and then you give it the power. Some of them you got to give it the power first, and then the E button. But anyhow, that's that. You don't have to do it in Excel. There's no reason to do it in Excel because it's really, really simple. Okay, the last one we want to talk about is the payment formulas, right, for doing mortgages and things like that. Well, so here's your payment formula. Remember that we already did this one in Excel. That's what this second one, the payments column, was in Excel. So 9%, right, making monthly payments for 10 years on a starting principal of $7,500. We do 9,501. That's what we got there, and that's this situation here, right? Here's our 7,500, 9% interest, N is 12. And our Y is 10. You can't see it over there off the side of the screen. So here's that big fancy payment formula that if you had to do it, in your calculator, it's not that easy. You could try to do it all at once, with parentheses, and it is doable, but I think it's better to do it in pieces. But anyway, I'll show you how to do it all at once. All right, so let's try this one. 7,500 times, you really don't need these parentheses, but 0.09, right? It's safest just to do everything you see. And then we have to divide by this whole fraction, right? So divided by, and then the whole fraction, so we got to do parentheses. 1 minus another set of parentheses. And you'll notice that we can't do square ones. They're all going to look the same. You just got to keep track of them. 1 plus, and then 0.09 divided by 12. Close the parentheses, and then raise it to a power. Fill that power in. You'll see that it's negative, right? In the formula, it's negative n times y. So you got to use the negative button down here. Don't do minus. Minus is wrong. You got to do the negative button. Otherwise, it'll give you a syntax error. 12 times 10. Again, of course, you could have just put negative 120 if you wanted to. You have to arrow over on this thing to get out of that power, and then close that final parentheses, right? Because you're closing that parentheses. And if you hit enter, as long as we typed everything in correctly, there it is, 95.006, which rounds to 95.01. Now again, that's a lot of stuff to do all at once. It's not the easiest thing in the world, so maybe you want to do it in bits and pieces, and then you just have to remember order of operations. Okay, so let's try it without all the parentheses. You'll notice my calculator has changed because my other software just kept crashing. So let's try this one. You're going to go ahead and do the bottom stuff, right? So you're going to do 1 plus 0.09 divided by 12 equals, there's that. We need to raise that, right? So raise that to the negative, and I'm just going to put in 120, hit enter. So that's that bit. And then you need to do 1 minus that. Well, you could do that minus 1, right? Or you can do times minus 1, enter. So there is a minus. Now we can do plus 1. So there's my 1 minus it. So now I've done all of this stuff. And now it's just a matter of the top being divided by that, right? So this is where it gets tricky, because the only way to work with this is you have to store it now. And then you're going to have to do the top number, 7,500 times 0.09 divided by 12 equals, there's that, and then you would divide that by, and then you have to recall it. Second, recall alpha A, and then hit enter, and there it is, right? Big pain in the butt, but it can be done. If you don't know how to store and recall, then you could do this bottom, like we did, and get this big long decimal, and then write that big long decimal down. Then do the top, get the 56.25, and then literally just type in, divide by, and write in this big old decimal. What's going to happen is maybe this last number down here might be different, right? Because the calculator is keeping decimal places far beyond what it's displaying. So when you just keep what's displayed, you've in essence rounded it off. But when you have that many decimals, the rounding error is going to occur so far down in your answer that when you round it to 2 decimal places, for money, it's not going to make a lick of difference. So that's the other thing too, is you can always do these things in steps and write them down and type them back into the calculator. Just make sure that if you do that, you write down every single decimal you can see on the calculator screen to keep it as accurate as possible. So basically to keep your rounding error as small as possible. And then that should guarantee that you get the right answer at the end, so that you basically do your final rounding only at the end. Okay, so those are the 3 ways to tackle these things. And it doesn't matter how complex the formulas are, just use this same technique, or do it in Excel. Thanks for watching.